In this video, we're going to look at case 4 under AFM Unit 5, and in this particular case, we have been given a table of daily stock prices for a few stocks. We have to calculate returns and major statistical parameters. We have to check how many days the returns were positive. We have to check how many days a combination of any two of the stocks gave positive returns, and we have to do a quick test of normality. Normality is normal distributions with the distributions of the returns, and discuss the variability of returns of the various stocks given to us, right? So what is the range of those returns that we are seeing? We will have to kind of work with those, right? So all this data is available on the Excel file. So that's the data available. We have for three stocks, DLF, iShares, and Hindalco, and we have this for the last 2 years that is available. So step one is we have to calculate the returns for these three. And so the returns are nothing but today minus yesterday divided by yesterday. And we can drag it here. That's the formatting issue. So we need to put these in percentages, add a decimal point, double click, right? So these are the returns which are available, and we can just copy and say DLF, iShares, and Hindalco, and these are the returns which are available with us, right? Now we've been asked to calculate major statistical functions. So we're going to look at mean, we're going to look at median, we are going to look at what is the max number, standard deviation. We're going to look at the maximum number. We're going to look at the minimum number, right? So those are the key parameters we're going to look at. So this is going to be the average, and that's the data. Median is going to be calculated using median. So how many are above a certain value and below a certain value? STDEV. P is going to give me the standard deviation, and I'll convert this to percentages as well. And we're going to look at max, which is what is the highest return for DLF. We're going to look at min, so what's the lowest return for DLF. We can also calculate something called as range, right? And range is nothing but the difference between the highest and the lowest return. So there's a 35% range that comes out here. We can add a decimal point to these just to see what the mean median are, and we can just drag it on the right side. So that's the information we get. Obviously, standard deviation of DLF is the highest, followed by Hindalco, followed by iShares. The range of returns is highest for DLF once again, as would be expected given that the standard deviation is the highest, right? That's the first task done after calculating the returns, which is we have now identified what are the major statistical parameters. We now have to count number of positive return days, right? That's what has to be calculated now. So I'm going to just make this a little bit wider so it's easier for us to kind of comprehend and read. How do I do that? So first we can find the total number of days, which is the count, and we can do a count if. And what is the count if? That's this. Criteria is greater than 0 and close. So 249 days are greater than 0, right? And what's the total days? Is nothing but a count of this. So out of 493, 249 are positive and 249 are negative, approximately right through the middle. You will find approximately right through the middle in terms of the number of positive return days that is there. And we can also find out days above mean return and that's gonna be count if this range is greater than the mean return, which is available here, right? So this formula is not going to work directly. If I do this, it's going to give an error because it has to take the greater than symbol in inverted commas, but then it can't take E500 in inverted commas because otherwise it will convert that to value. So we have to use ampersand symbol here. So that's what it does. It takes greater than, puts that as a text string, and adds that to E500. Click on OK. So number of days above the mean and below the mean. So days above mean return, days below mean return is what we have calculated. And consequently days below mean return would be equal to A minus B. So, largely symmetrical nature of returns that is there. It'll be important when we do the normality calculation. Now we also want to find out the number of days two of the stocks give positive returns. Two of the stocks give positive returns. Now any two can be selected. So we have DLF, we have iShares, we have Hindalco, and we have these three here as well. So I'm going to do a transpose and paste it here. Right now, DLF with DLF should give me the same count if. Now, think about it. What I want to do is I want to find out the number of days which are positive here and number of days which are positive here. So either I do if this is greater than 0 then 1, and if this is greater than 0 then something, and then I count that. So count if this is greater than 0 and count if this is greater than 0, but that'll do it individually, right? What I want to do is if this is greater than 0 then 1, else 0, that's 1. Similarly, if this is greater than 0 then 1, else 0, right? Now, as long as I can do that, we will note that the days when both of them are 1 are greater than 0 is what has to be found. So in these 5 days, these 3 have to come. So what I can do is if I can multiply these two data points, 1 into 1, then essentially I should be able to get the count of the number of days, which is, and then sum these. So 3 days is the sum, right? So first multiply these arrays and then add this. Multiplying and adding is a function that we already have, which is called as sum product. This is going to be one array in sum product. This is going to be the second array in sum product. So what I'm going to do is I'm going to go to this set of data and I'm going to use a function called sum product, and within sum product we are going to mention a few things. So this array is going to be if this set of data, and we'll freeze this by pressing F4, is greater than 1, is greater than 0, then 1, else 0, right? You see there is an array that is coming out here. The second one is if, we'll freeze this E6 also, sorry, right? The second one is if the first set of data again, and this time I want to freeze only the rows, not the columns. When I drag it on the right side, I want it to be working well, right? And if this is greater than 0, then 1, else 0. And you see another array coming out. And if you do a sum product, it should ideally give you the answer of 249 here. It should ideally give you the answer as 249 here. that you see, but these are array functions. This is an array, this thing. So if I click on OK and I leave it here, it's going to return an error, right? And the error is essentially because it's an array function, right? It's an array function. So I need to press Control Shift Enter. Control Shift Enter. So I need to go into the function here and then press Control Shift Enter, and we see 249 days is when the stocks gave positive returns. That's the number we found here, 249 days when the stock gave positive returns, right? That's DLF with DLF. Now if I choose DLF with iShare, that should be this value, and so on and so forth, right? Now when I drag it down, then I need iShare with DLF and so on and so forth. So I can do the same once again. I can do some product. So we can do some product, and within this we can write if, and we can start with iShare first, and that's gonna be iShare if this freeze is greater than 0, then 1 else 0, comma, if the first one now, if this, and we freeze only the rows in this case, E greater than 0, then 1 else 0, and we do a Control Shift Enter, right? So that we didn't put a bracket at the end, so that gave the issue, and that gives me 153 days where DLF and iShare are kind of positive. We drag it on the right side. We find 251 days when iShare is positive and 148 days when both iShare and Hindalco are positive. And similarly, the last one is sum product if the final one, frozen, is greater than 0, then 1 else 0, comma, if the first one, and freeze only the rows, greater than 0, comma, 1 else 0, close brackets, Control Shift Enter, and we should get the data. So what do we get? 166 days. That's the number of days we saw, and I can just drag it on the right side. We already have all of the data. Obviously the diagonals are the ones where only that stock is positive, which is this set of data that we calculated, and the others are the set of data points where any two of those. So 153 will be the same as 153, 166 with 166, 148 with 148. Somewhat similar to the variance covariance thing, but we've obviously taken the idea of using sum product, if, and array functions together, right? Now we finally want to kind of find out what the ranges are. So what I'm going to do is, this is mean, this is -1 standard deviation, and let's actually put a this here, so it shows that. Then -2 standard deviation and -3 standard deviation. So -3 standard deviation, right? And this is equal to +1 standard deviation +2 standard deviation +3 standard deviation, SD, right? That's what we do. So what's going to be the mean for these guys? That's the mean number that we have. We can put the mean here. -1 standard deviation is equals to this minus whatever is the standard deviation, and click on, sorry, I've put this here, so remove this, and then, sorry, Control Z, this minus the standard deviation which is here, and this minus the standard deviation, which is here. Similarly, it's this plus the standard deviation, which is here, plus the standard deviation 3.25%, plus standard deviation 3.25%, and we can drag it on the right side. Right, so those are the set of data points which are there in terms of the standard deviations. Obviously, the ranges are going to be bigger for this data. Sorry, I think the last one is incorrect. That's this plus the standard deviation, right? So the ranges are much bigger for DLF. Now, let's look at the distribution of DLF. So what we are saying is, let's take them one by one. That's DLF, and that's the data for DLF. That's the data for DLF. So I'm going to put DLF here, Control Z. Let's paste it as values and formats, right? And now I want to find out the frequency function. Remember, data array is here. That's my data array, frozen, comma bins array. So that's my bins array, right? Frozen. And I close this and I press enter. So that doesn't give the correct picture. I select one extra cell and press Control Shift Enter. That's my distribution, right? That's the distribution we have. And once we have this distribution, we can plot it. What we can do is we can find out the total number, which is 493 in all the cases, and just divide each of these by 493 to find out what is the percentages, right? So you find that roughly, let's just do this. Let's roughly between 1 and -1, you have 77, then you have 95, then you have 98 in 3 standard deviations, and outside that is what is left beyond that, right? So that's what we have here. Next, we do the same for Aisher, and you plot the same data for Aisher, and we can select this bit as values and formats, and I can do the frequency calculation here. So that's frequency. What's my data array? That's Aisher. That's the second one, frozen, comma bins array. That's this one, frozen. Close, enter, select one extra, and Control Shift Enter. So we get this here. I can do the same calculation here, is equals to this by 493, and drag it down percentages wise, 75%, 94%, 99% or 98% kind of a thing, and then less than 3 and more than 3 is another 2%. So approximately similar kind of distributions that we're getting. And the third one is going to be Hindalco. I'm going to copy this quickly. We're going to go up here, copy these ranges quickly, values and formats, frequency, what's going to be the data that we're going to use. That's going to be this set of data, frozen, comma bins array, frozen, enter, select an extra cell, Control Shift Enter. So that's the data we get, is equals to this by 493 days, and we do this, right? Now what we can do is we can do a calculation of DLF, Aisher, and Hindalco, and this could be linked here, this could be linked here, and this could be linked here. We can just drag it down till here, and we can just compare the data points with each other, right? Let's say we'll insert a row here. That's the set of data that we get, that we find that these two are largely the same in terms of their numbers. The third one is 71%, 71% and 96 and then 99. So it seems like Hindalco is more closer in terms of actual percentages. Remember, these two have to be 68, these two have to be approximately close to close to about 95, and these put together approximately have to be about 99. So that's the ranges that we are getting. In general, what you'll find is about 34%, 34% here. Then that's 65. Then you add another 27. So that's 13 and a half. So 13.5% here and 13.5% here. So that adds up to approximately 95. And then 2.5%, 2% here, approximately 2% here and 2% here. Those are the broad ranges that should happen with an exact normal distribution. And because we are using the market data to kind of find out, we are finding that this is how the variability works. That's what we have identified in terms of the normality of distributions of these three. If we want, we can also plot them on a graph, and we can get the data. Something we have tried earlier in one of the other topics or subjects that we have seen. But that's the comparison that we have done. So that finishes the task. Broadly, just a quick recap. We calculated the statistical parameters with the data and the returns. How many days returns were positive? We used COUNTIF. How many days? A combination of two. We used sum product. We used if within sum product, and we used an array function there. Normality, we used frequency function, which is an array function as well. Right? So those are the calculations we have done for case 4. That's it in case 4. Thank you.